All right, AP Stats, today we're going to talk about conditional probability. We have done conditional probability, actually, we just haven't talked about it in these formal terms. Okay, so the symbol here for conditional probability is this line. And what this means is the probability of B given A has occurred. So knowing A has occurred, now what's the probability of B? And this is the formula for that. And you'll find this formula on your pink sheet. Okay, and the difference between the first formula and the second formula here is absolutely nothing. They're the same formula, but just written differently. Okay, so if you multiply both sides by probability of A, you would get the second formula. So they're exactly the same, but sometimes we use it in the first way and sometimes we use it in the second way. Okay, so the first thing we're going to do with conditional probability is just use some common sense. Again, we've already talked about this, so this should be no problem for you. So what is the probability of drawing a red ball from a box that has 3 red, 4 blue, and 1 white, given that a blue one has already been drawn and not replaced? So actually what has happened is that this is no longer 4 blue, this is now 3 blue. We took one out, we set it aside, and therefore we want the probability of a red given a blue has already been drawn. So now we are down to 7 total, and 3 of them are red, so 3/7. Okay, and then what we have here is conditional probability using tree diagrams. So we can use tree diagrams when we've got multiple things going on top of each other. So here we have a 1-in-1 shooting foul. This guy's an 80% free throw shooter. For those of you that don't understand 1-in-1 shooting, you get one shot and either you make it or you miss it. If you miss it, you're done. Game continues. If you make it, you get a second shot. And then if you make that, you get another point. And if you miss that, you get just the 1 point from the beginning. So you have a possibility of getting 0 points, 1 point, or 2 points. Okay, so now what is the probability of making both shots? So that has to be a make. That would be worth 2 points. So that's going to be 80% that you make, 80% that you make again. And here we are actually assuming independence. Okay, the problem should say that one shot is independent of the one before that. So 0.8 times 0.8, that's going to be 0.64. So he has a 64% chance of making both shots. Next we have, what's the probability of scoring at least 1 point? Okay, well, scoring at least 1 point is going to be either getting 2 points or 1 point. So we're going to say this is going to be the probability of 1 point plus the probability of 2 points. We already found the probability of 2 points is 0.64. So the probability of 1 point means you make, then miss. So that's going to be 0.8 times 0.2, which is 0.16. So 0.16 plus 0.64 equals 0.8. So that is the probability of at least 1 point. Or what we could have done is used our complement. Probability of at least 1 point is going to be 1 minus the probability of 0 points. And we found here 0 points is 0.2. So 1 minus 0.2 is 0.8. You could have attempted this problem either way. Now we're going to use tables. We've actually done tables. We did this in chapter 4. We're going to see it again. It's exactly the same thing. So what is the probability that a randomly selected student is a firstborn or only child given that they are in education? So here is education. So we're only looking at those education people. So we're only looking at a 93. And we want to know what is the probability that someone in education is a firstborn or only child. So that's right here. That's going to be 52 out of 93. Again, we did this in chapter 4. Now using the specific formula. Okay, so here we have girls and boys asking about their goals of high school, whether they want good grades, to be popular, or to participate in sports. 19% of all students were girls whose goal is to be popular. Okay, 52% of all students were girls. What is the probability that a randomly selected girl, so given she was a girl, knowing it's a girl, What is the probability she had a goal of being popular? So we are only talking about girls. So using the formula, we want the probability that someone is popular given that they're a girl. We're only talking about girls here. The formula says probability of popular and girl divided by probability of girl. Notice that when you're using this formula, that your given here is what goes on the bottom. So out of the 52% of girls, 19% wanted to be popular, so 19% out of 52% is 36%. Okay, so that's how the formula works. Lastly, we can use the formula to determine if events A and B are independent. Again, when we did the cards, the ace, the diamonds, all that stuff, we actually used this formula. We just thought through it instead of using the symbols. Okay, so what is the probability of A given B? Well, that's just going to be the probability of B if it didn't matter if we were given A. So events are independent if the outcome of one does not affect the outcome of the other. So if A is not affecting B, then the probability of B given A has occurred is the same whether A has occurred or not. So that's going back to that, which we use common sense probability. You can see the formula here of how that works. So no example problems to do for tomorrow, but just make sure that you're ready to go.